Now let's take up question number 25. Here you can clearly see we have a choice in this question and both the choices are on basis of finding derivatives. So you can opt for any of that. So in the first choice it has been stated if x is equal to a cos theta and y is equal to b sin theta, then find d2y by dx square. While in the second choice you have to find the differential of sin square x with respect to e raised to the power cos x. So this means you have to find the derivative of sin square x with respect to e raised to the power cos x. So let's proceed with the first choice, as here the value of x and y is given in terms of theta. To obtain its derivative, very first we need to differentiate both the sides with respect to theta. So as we clearly have x and y, let's differentiate both x and y with respect to theta. So dx by d theta will be equal to minus a sin theta, as derivative of cos theta is minus sin theta, and here derivative of y with respect to theta will be b cos theta, because derivative of sin theta is cos theta. Now as you have obtained dx by d theta and dy by d theta, using that we will obtain here dy by dx. You know dy by dx will be equal to dy by d theta whole by dx by d theta. Taking that case into consideration, we substitute these values and on simplification you will obtain cos upon sin is cot. So dy by dx is minus b upon a cot theta. But here we just need not to obtain dy by dx, we also need here the value of d2y by dx square. So again it will be differentiated with respect to x. Further, on differentiating it again with respect to x, you will get here d by dx minus b upon a cot theta. So as it is in terms of theta, so it needs to be differentiated in terms of theta. So applying chain rule here, I get here constant minus b upon a into d cot theta upon d theta whole into d theta by dx, where already I know the value of dx by d theta is minus a sin theta. So this is reciprocal of that. I will be obtaining here 1 upon minus a sin theta. And here derivative of cot theta will be minus cosec square theta. And cosec square theta is basically reciprocal of sin square theta. So this can be further reduced in terms of 1 upon sin square theta. Minus minus get cancelled and finally it results here the value minus b upon a square sin cube theta. So we get here the value of d2y by dx square as minus b upon a square sin cube theta. So this is the final answer for this question. So this was a 2-marker question. The step where you obtain dy by dx, in this step you will obtain 1 mark and rest 1 mark will be obtained when you finally obtain d2y by dx square. So there you get total 2 marks for this question. Now proceeding through the choice given in the same question, you have to differentiate sin square x with respect to e raised to the power cos x. So let's consider here u is equal to sin square x and v is equal to e raised to the power cos x. So firstly I will be obtaining du by dx and then dv by dx. So we have u and v respectively, we differentiate both of these with respect to x, resulting here du by dx equal to 2 sin x cos x, because derivative of sin square x with respect to x is 2 sin x and derivative of sin x is cos x. Further, on differentiating v with respect to x, we get e cos x into minus sin x using chain rule. So we have here du by dx and dv by dx, but in this question we need derivative of sin square x with respect to e raised to the power cos x. So we need here du by dv. So du by dv can be easily obtained by considering du by dx divided by dv by dx. So here we get du by dv as du by dx and upon dv by dx. Substituting these values we get here 2 sin x cos x upon minus e raised to the power cos x into sin x. Sin x gets cancelled and here this term could be brought in the numerator by having a minus sign in its exponent, resulting here the final value of du by dv. So we get here du by dv equal to minus 2 cos x into e raised to the power minus cos x. तो फाइनल आंसर आ गया आपका minus 2 cos x into e raised to the power minus cos x. This was a 2-marker question, and in this step where you obtain here du by dx and dv by dx, here you get half of marks for each, resulting 1 mark for this step, and final answer will be obtained as du by dv, and for this you will get rest 1 mark, which gives you total 2 marks for this question. I hope it's clear to you. Now let's move on to question number 26. This is a very interesting question from the definite integrals. Here it states, find the value of integral with limit 0 to 1 tan inverse 1 minus 2x upon 1 plus x minus x square with respect to x. So here in this case, very first we need to consider this as integral I. So I am considering this as equation number 1. Next, I want you to recall a very important property of the definite integral, that when we have integral 0 to a fx dx, that can be also written as integral 0 to a f of a minus x dx. So that means here in place of a I have 1, I can substitute this x as 1 minus x. So taking that into consideration, this integral I becomes integral 0 to 1 tan inverse 1 minus twice of 1 minus x, while in the denominator you have 1 plus 1 minus x minus 1 minus x whole square. When you expand this 1 minus x whole square, you get here 1 minus 2x plus x square, and here you get 1 minus x. जब इस पूरे को सिंप्लीफाई करेंगे तो डिनोमिनेटर वापस से क्या आ जाएगा, 1 plus x minus x square. लेकिन न्यूमरेटर में आपको वैल्यू मिलेगी 1 minus 2 plus 2x, which simplifies to the value 2x minus 1. So in the next step, you will see that here the numerator is similar to the previous one after taking minus sign as common. So I'll be taking here minus sign common. I am left out with 1 minus 2x upon 1 plus x minus x square. So as you are aware, tan inverse minus x is equal to minus tan inverse x. So taking that case into consideration, I can write this integral I equal to minus of integral 0 to 1 tan inverse 1 minus 2x upon 1 plus x minus x square. So here I am considering this as equation number 2. So we have here equation number 1 and we have here equation number 2. So equation 1 and 2, when you clearly see that here left hand side is same and in the right hand side we have the same quantities in magnitude but signs are different. So when I'll be adding up these two, left hand side will get added up and give you here I plus I 2i, while right hand side will get completely cancelled out. Here you can clearly see that in this case, this is integral I and this is also integral I, but equation number 2. This RHS will get cancelled up and you will be getting here the value on adding these two as 2i equal to 0, resulting the value of I as 0. So the value of this given integral is equal to 0. And how easily you have solved this using the properties of the definite integrals. So in this question you will get complete 2 marks. On application of this property here in this step, you will get 1 mark and rest 1 mark will be obtained on obtaining the value of this integral I equal to 0. So in this manner you get total 2 marks for this question. I hope it's clear to you. Now let's move on to section C containing 4 marker questions.